In this example, we're told that this simple random sample of size n is drawn from a population that's normally distributed. So in this case, we don't have to check for those particular conditions. We're told the sample mean is to be 115, sample standard deviation, S, is to be, or found to be 10. And we're asked to construct several different confidence intervals with different sizes of n, sample sizes. For this particular problem, I'm going to use the TI-84. To me, it's just a little bit quicker. So to construct a confidence interval, I would go to Stat. I'm going to scroll over to Test, and I want to select T interval. So that's number 8. Now, if I had the data, I would refer to it, what list it's in, but in this case, I have the statistics. So I want to select that option. I'm going to type in the sample mean, 115, and the sample standard deviation, which was 10. Give it the size, the sample size. In part A, it is told to be 12, and we want the confidence level to be 0.9, 90%. We calculate, and here we get the lower and upper bounds of the confidence interval, or the T interval to be exact. Notice that you're asked to round to 1 decimal place. So in part B, I'm just going to do this again with a different size n. So I'll go back through Stat, Test, T interval, keep everything else the same except for n. N is now 29, and calculate. Again, I have the lower and upper bounds. Next, we're asked this comparison question. How does increasing the sample size affect the margin of error? Now, if you'll notice, as the sample size increased here, everything else staying the same from parts A to part B, the upper and lower bounds got tighter. So in other words, the margin of error decreased. You're asked to do part C with a different confidence interval. So again, I can just come back to Stat, Test, T interval, and type in this new information. And I have now my new lower and upper bounds. And again, I just rounded to 1 decimal place, 108.3 to 121.7. We're asked to compare these results to what we obtained in part A. So consider this interval compared with what you had in part A, which is actually a smaller interval. So what happens as we increase the level of confidence is the size of the interval increases. That makes us more confident that we're capturing that mean. Could we have computed the confidence intervals if the population had not been normally distributed? Now, in order for the T interval to work, we need to have a normal distribution. So no, this population needs to be normally distributed.